Alright, in this video I'm going to show how to use the sum and difference formulas to find exact trig values. Alright, 12ths, that's not on the unit circle, so usually we would not be able to find the exact value of cosine of 11 pi over 12. But if I rewrite that as cosine of 3 pi over 12 plus 8 pi over 12, that does add up to 11 pi over 12, and then I can simplify both of those fractions. 3 pi over 12 simplifies to pi over 4, and 8 pi over 12 simplifies to 2 pi over 3. And now I can use the sum formula for cosine. So I'm going to rewrite that as cosine of the first angle times cosine of the second angle. All right, and then we're going to subtract the sine of the first one, so sine of pi over 4 times sine of the second one, sine of 2 pi over 3. All right, and now all my angles are on the unit circle, and so I can get exact values here. Cosine of pi over 4 is square root of 2 over 2. Cosine of 2 pi over 3, that is negative 1/2. Sine of pi over 4, that is square root of 2 over 2. And sine of 2 pi over 3 is square root of 3 over 2. And then multiplying here, I would get negative square root of 2 over 4 minus, I'll just put this all over, it has the same denominator, so I can combine numerators here, so it would be minus the square root of square root of 2 times square root of 6, or 3 is square root of 6. And that's done. Okay, on this next one, I'm going to use the difference formula for sine. And as you do these, you'll notice that with 12ths, we're going to rewrite that as either the sum or difference of fourths and thirds. You'll see that pattern. All right, so sine of negative pi over 12, I'm going to rewrite that as sine of 3 pi over 12 minus 4 pi over 12. And that does indeed simplify to negative pi over 12. And now I'm going to simplify each of those fractions just a little bit. So sine of 3 pi over 12, that's the same as pi over 4. And 4 pi over 12, that would simplify to pi over 3. Okay, and now I need to use that difference formula for sine. So that is sine of the first one, so sine of pi over 4, times cosine of the second one. Okay, and then that's minus cosine of the first one, so pi over 4, times sine of the second one, which would be pi over 3. And now those are all angles on the unit circle, and so I can plug in my exact values here. Sine of pi over 4 is square root of 2 over 2. Cosine of pi over 3, that is 1/2. And cosine of pi over 4, again, that's square root of 2 over 2. Sine of pi over 3, that's the square root of 3 over 2. All right, and now just multiplying and combining numerators, I would get the square root of 2 over 4, and now square root of 2 times square root of 3 is minus the square root of 6. And that is done. All right, on this one I'm going to use my sum of sine formula to prove this identity. And with a proof, we are only working on one side of the equation. So I can't manipulate both sides, I'm just going to work on one side of the equation. So I'm going to replace this sine of pi plus theta using the sum of sine formula. So that would be the sine of the first one times cosine of the second one, so cosine theta, plus cosine of the first one, so cosine pi, times sine of the second one, so sine theta. All right, and now wherever I can, I'm going to find exact values. Sine of pi is 0, so that's times cosine theta, but that's just 0. cosine of pi is -1 times sine theta. So that simplifies to negative sine theta, which was what we were intending to prove. So we're done. Now I need to use my double angle formula. So I'm given sine theta and I need to find cosine theta. So looking at our double angle formulas, because I'm given sine, I'm going to use this equation that has a sine in it. So my cosine of 2 theta, I'm going to replace that with 1 minus 2 times sine squared theta. And using substitution here, that would be 2 times sine, but sine is equal to 24/25. So that goes in and is squared, and now squaring the square of 24 is 576, and the square of 25 is 625, and multiplying 2 in my numerator there, I would get 1 minus 1,152 all over 625, and I'm just going to replace that 1 with 625 over 625 and just subtract my fractions there. So that final answer is negative 527 all over 625. And that's what my cosine of 2 theta is equivalent to.